It's our last one for the night. Gonna do lecture example number 6. Number 6. In lecture example 6, it tells us that 55 grams of magnesium carbonate react with excess aluminum. So in terms of limiting an excess reactant, I don't have to worry about that because it tells me that aluminum is the excess reactant. And 45 grams of aluminum carbonate are actually obtained. What is the percent yield of the reaction? So let's write out the reaction. It is magnesium carbonate reacting with aluminum. That's going to form magnesium, single replacement reaction, plus aluminum carbonate, Al2CO3. And we would want to balance that because you always have to have a balanced chemical equation. And that's going to be, I need 3 of the carbonates, so that's a 3 there. That gives me 3 magnesium, so that goes there. And there are 2 of the aluminum, so that needs a 2 there. So it'd be 2 moles of magnesium carbonate with 3 moles of magnesium carbonate with 2 moles of aluminum to make 3 moles of magnesium and 1 mole of aluminum carbonate. Told me that aluminum was in excess, so that's just chemistry teacher way of saying don't worry about it. And that we use 55 grams of magnesium carbonate. Then it tells me, kind of weirdly, if you've worked out a few of these problems, that you get 45 grams of the Al2CO3, and then it wants to know what the percent yield is. So percent yield is equal to the actual yield divided by the theoretical yield and then made into a percentage. So what that 45 grams is, that's them telling us that that is the actual yield. That's how much you actually got. But theoretically, you probably could have gotten more than 45. How are we going to determine the theoretical yield? We are going to use the amount of available reactant and determine how many grams of aluminum carbonate could we have made. If everything had gone perfect, what's the maximum amount of aluminum carbonate you could get with 55 grams of magnesium carbonate as your initial amount? We're going to work a stoichiometry problem. We're going to convert grams of magnesium carbonate to moles of magnesium carbonate. Moles of magnesium carbonate to moles of aluminum carbonate. Moles of aluminum carbonate to grams of aluminum carbonate. So a nice 3-step stoichiometry, sort of at this point a typical stoichiometry problem. 55 grams of magnesium carbonate times 1 mole, because that's what we want to convert to, of magnesium carbonate for a certain number of grams of magnesium carbonate. Go to your periodic table, add that up. So magnesium is 24.30 plus carbon is 12.01 plus 3 oxygens, and that I think adds up to 24.3 plus 84.31. 84.31 grams of magnesium carbonate. We're going to convert that now that we have moles of magnesium carbonate. We'll convert that to moles of aluminum carbonate. It is 1 mole of aluminum carbonate for every 3 moles of magnesium carbonate. Moles of magnesium carbonate are going to divide away, leaving us with moles of aluminum carbonate. And then we're ready to convert that to grams. So a certain number of grams of, oh, crying out loud, Bix, write the correct formula, of aluminum carbonate for every 1 mole of aluminum carbonate. So we need to add up how many grams per mole is aluminum carbonate. So that's 2 aluminums, 3 carbons, 9 fingers of it, 9 oxygens. Add it all up, I got 233.99. 233.99 grams for every 1 mole. So multiply, you get 55 times 1 times 1 times 233.99 over 84.31 times 3. So 84 times 3, that's going to be about 240-ish. So that can't. So you're going to get about 55 grams of aluminum carbonate. So we'll multiply that out for real. $50.88. So I got that our theoretical yield is 50.88. Now you can keep that, or you can round it to 2 significant figures. Here with the dividing, it doesn't really matter. So we get that our percent yield comes out to be 88. Now we're going to round it to 2 significant figures. 88%. So that is our percent yield. And that's how you do it.